Today, instead of because of coronavirus, we have today a rather strange edition of the Work Meetup. So, my name is Ivan Krutov, and today I'm going to talk about the Chrome Developer Tools Protocol. How what is Chrome Developer Tools Protocol? How to use it and how to scale it in Kubernetes cluster. So, a few words about me. Being a software developer during the last decade, my main experience is related to Java and Golang programming languages. My main activities during the last 6 years are called with a buzzword DevOps. That means that I'm creating and maintaining various infrastructure. And one of the biggest products I'm working on is a big Selenium cluster. So how big is this cluster? Compared to a typical Selenium grid with 50 browsers and executing 10,000 browser sessions per day, this cluster has more than 5,000 browsers running in parallel and executing more than 2.5 million browser sessions per day. These browsers are distributed across 5 data centers. The average load is about 4,000 requests per second. The traffic is is more than 2 gigabits per second, and this cluster is certainly working all the time. So every minute it's executing more than 200,000 requests. So this cluster has all popular browsers and platforms, including last 10 versions of Firefox, Chrome, Opera, all versions of Internet Explorer, Microsoft Edge, Android emulators running on real hardware servers, iOS simulators running on Mac Minis, and for some teams we also have real devices, phones and tablet PCs connected to the same cluster. Some of you could also be using one of the tools we are working on, including Selenoid, an open source Selenium protocol implementation running browsers and Android emulators in Docker containers. Moon, an enterprise level Selenium solution running everything in Kubernetes cluster, and we also have an online platform called Browsers, which is similar to South Labs, Browser Stack, Testing Bot, and so on. So if you have any questions related to these tools, just contact us somehow using our support email and so on. I think most of you would agree that Selenium is nowadays a de facto worldwide browser automation standard. Meanwhile, we have an issue. Selenium has a lot of limitations, so there are a lot of operations that are impossible with standard Selenium. For example, we can't modify document object model tree using Selenium. We can change CSS styles only with complicated JavaScript expressions, which is very important. It's impossible to track network activities in a tested web application. We can expect accessibility tree, so we can test that our application is working correctly for people with disabilities. We can do any page tracing and profiling, how much memory it consumes, and we certainly can't subscribe to any events occurring in the tested web application. I think most of you have already seen this screen. This is called Chrome Developer Tools, which is a toolbar available in any recent Chrome version. And hopefully all these features I mentioned before are already accessible in this developer toolbar. And this toolbar is in fact a standalone web application using an API to interact with a Chrome browser. Internally, this toolbar is using so-called Chrome Developer Tools Protocol. So when you start a Chrome browser, it finds and allocates a free network port and starts listening for commands on this port. Chrome Developer Tools then just connects to this port using WebSockets and starts sending various commands to manipulate the browser. So knowing this, a very simple idea comes to our mind. We could use an available client-side library implementing the same Chrome Developer Tools protocol, and this is how we could use just the same powerful features in our automated tests. So let's first of all take a look at how Chrome Developer Tools protocol looks like internally, how this JSON data exchange format looks like. So in Chrome Developer Tools we have two types of interactions between the client and the server. The first one is called request and response model, and in that case we are always sending a JSON request like this, always having a field called ID, which is an integer which is incrementing for every new request. For every request we also have a field called method. For example, in this example, this method is page that captures screenshot. That means that we are taking a screenshot of the running of the web page. And optionally, we could also have a params section where we could send some additional parameters. For example, which extension we would like to use for taking the screenshot, the quality, and so on and so forth. So when we send a request, sooner or later we receive a response that will always contain the same ID field with exactly the same numeric value, and it will optionally contain a result field where we will get some result of our operation. So for example, in case of capturing the screenshot, in the result field we will get the all the binary data, all the bytes of the screenshot. So far as we are working using the WebSockets, this ID field is very important, just because for how to say, WebSockets is an asynchronous communication media. We can send a request and our response can arrive later. So in order to understand which response corresponds to which request, we should just compare these numeric values. Another possible interaction in the Chrome Developer Tools protocol is notifications. So in that case, you can subscribe to any events in the running web application, and sooner or later you will receive a message from the browser indicating that this event actually occurred. So, and knowing this, let's first of all take a look at how basic Chrome Developer Tools works out of the box. So here I'm demonstrating Chrome Developer Tools using a very popular library called Puppeteer. It's a library for Node.js. And first of all, we certainly install this library using Node Package Manager. While we are doing this, it automatically downloads a recent version of Chromium, which is an open source Chrome version. So we download this browser, and then we can implement a very simple test. So in this test, we first of all import the library, then we initialize this library, we launch the browser, then we open the page. In that case I'm using one of the popular conferences page. Then we take a screenshot, then we print the page title, and that's it. So here I'm running this test with an additional environment variable called debug. This is used to actually print all the JSON requests and responses that happen when we interact with the browser using the Chrome Developer Tools protocol. So I'm launching this test, and I'm seeing that we're actually getting the browser running. So it runs, it takes a screenshot, and here our test ends. So let's take a look at how a typical request and response look like in Chrome Developer Tools protocol. So here is a typical request. Here we are getting the page title. We are seeing that it has identifier equals to 12, and here is the real response to this request, and we can see that in response we are getting just the same identifier. And we can see that we are actually getting the page title, and we can open the screenshot and make sure that it works. So that's it. So that was the first demonstration. Okay, so we have now seen how Chrome Developer Tools protocol basically works, but usually in real life we need to run several browser instances in parallel. So this could be, for example, we could need to run several copies of the same browser versions as well as several different browser versions. And usually during the conferences, people are speaking about using the Chrome Developer Tools protocol locally, but nobody is explaining how to scale these solutions. And this is where Docker containers come into play. So as you know, Docker containers are a good way of isolating browser processes. So in order to be able to run several copies of Chrome Developer Tools, we need to somehow run several Docker containers with Chrome browser. The second issue that we will certainly encounter when trying to launch several copies of Chrome browser in parallel is browser cost. So any browser automation is really expensive, and so far as our web applications are becoming more and more complicated and thus require more and more automated tests to ensure their quality, this really influenced a lot how we are launching our browser automation during the last 10 to 15 years. So first of all, from 10 to 15 years ago, everybody was running real hardware servers, one or several hardware servers. Sometimes they were running in the neighbor room, and we were using a Selenium Grid installed on top of these hardware servers. But sooner people understood that using dedicated hardware servers is too expensive, and a very simple idea came to their mind. We could just install a particular software and divide our dedicated hardware server to small pieces and use every piece for a different application, different domain. And this is how virtualization software like VirtualBox, VMware, CAM, and so on appeared. So later, smart guys from Amazon understood that it would be great to install a lot of hardware servers to data centers and then sell small virtual machines with a lot of profit. And this is how public cloud platforms like Amazon Web Services, Google Cloud, DigitalOcean, and so on appeared. So 5 years ago, we were already running Selenium Grid on one or several virtual machines in one of private or public cloud platforms. So cloud platforms and virtualization successfully fixed the browser automation cost problem, but they didn't influence the automated test stability. And this is where Docker containers came into play. So providing an efficient and really fast isolation between browser processes, they revolutionized how we are running our automated tests. So last 3 years we were running our automated tests using one of available solutions using Docker containers. So for example, selling on it. Nowadays, as you know, our applications are becoming more and more complicated, and require more and more browsers to test them, and we still need the first-class browser isolation between browser processes, but we need even more efficient solution to optimize browser automation cost. And here, the new type of systems called container cluster management systems like Kubernetes, Apache Mesos, and Docker Swarm are becoming more and more popular. So these systems are allowing to automatically distribute any number of containers on top of any number of virtual machines or hardware servers, and they also provide some primitives to better communicate between containers and to better exchange the data between them. So, currently, different teams are using any of these tools, both Kubernetes, Apache Mesos, or Docker Swarm, but it seems that it's Kubernetes that is becoming a de facto standard in container cluster in container cluster systems. So today I would like to mainly talk about Kubernetes. So the first question is how a QA automation engineer could get a Kubernetes cluster. There are several ways to do this. The first one is just by installing a regular Docker distribution from the official website. So having a Docker, you can just enable a Kubernetes option in settings and get a running Kubernetes cluster in minutes. Another option is using Minikube, which is a standalone binary that you can download from their official website, launch a single command, and get a running Kubernetes cluster, which will be using some virtualization technology. For example, in Windows it will be using Hyper-V, and Mac it will probably be using VirtualBox, so whichever is available. For the first two approaches are mainly useful for playing with Kubernetes. So for education as well as for production cluster purposes, you could easily use one of the available public cloud platforms such as Amazon Web Services, DigitalOcean, Google Cloud, Microsoft Azure, and so on. In these platforms, a Kubernetes cluster is usually being run on top of one or several virtual machines, and you're usually paying only for the cost of the computing resources consumed by these virtual machines. So in case of big companies, you could also get a ready-to-use Kubernetes cluster, which is usually deployed by a dedicated team of DevOps engineers, and which is usually deployed on top of hardware servers or virtual machines in the cloud. And in that case, to get a running Kubernetes cluster, you just need to go to this team and ask them for a project or a quota in this Kubernetes cluster, and then start using it. So having a Kubernetes cluster, how could we interact with this cluster? There are certainly several possible ways to do this. The first one is using a REST API. So Kubernetes, like any modern web application, has a REST API with authentication and authorization features, and you can certainly use this API with any available open source client library that is compatible with this API. There are a lot of client-side libraries for different programming languages. A lot of users will certainly communicate with Kubernetes using a dedicated command line client tool called kubectl, and like all the rest of Kubernetes, this tool is implemented using Golang programming language, and you can just download the ready-to-use binary for your architecture from the GitHub or from the official Kubernetes website. Some users will prefer to use a graphical web interface for Kubernetes, which is usually, in the majority of cases, distributed as a web application. So the last thing we need to know about Kubernetes is how it differs from the regular Docker. So there are several important Kubernetes concepts to know about. First of all, Kubernetes has project support. They are called namespaces, and every namespace is completely isolated from another one, and allows Kubernetes cluster administrator to assign any number of computing resources to every namespace. So instead of regular containers, we have pods, and this name pod comes from a pod of peas, where instead of peas we have regular containers. Such approach, so far as all these containers have just the same IP address, such approach allows to easily exchange the data and easily do any network communication between relative groups of containers. In order to communicate between different parts of our application, or between different applications, Kubernetes provides a concept called services. So service is basically a thing that provides a constant domain name for one or several pods, and allows to adjust a load balancing strategy for this set of pods. The last Kubernetes concept that we need to talk about is called deployment. Deployment is mainly needed to ensure that in your cluster you always have a required constant number of copies of your application, called replicas, always running. So this is mainly needed for fault tolerance purposes. So which is very important in case of browser automation, is that we need to somehow provide a single entry point to our cluster. So we would like to send our browser automation request to a single host name or a single IP address, and to be able to somehow redirect our, for example, Chrome Developer Tools requests to an actually running browser, to an actually running Kubernetes service. In order to provide a first-class isolation level between browser processes, we need to use a short-running containers or pods in Kubernetes. That means that for every new browser session, we need to run a new pod, and we need to remove this pod at the end of our browser automation session. So all these approaches were already implemented in one of our solutions called Moon, but today I would like to mainly show you how you could use a Chrome Developer Tools protocol in your real life, so which features are already available. So let's take a look at the videos now. Okay, so first of all, I'm showing here a stuff called Chrome Developer Tools Protocol Viewer, which is like a documentation for the entire Chrome Developer Tools protocol. So here we have the JSON definitions, which are usually stored in the Chromium source code. Here we have different domains, that means different parts of Chromium browser. For example, here we have a section called network, and it allows to track network activities. We have a section called browser that allows to modify different browser global settings. So for every section we have two subsections. The first one is called methods. So here we have different method definitions. These names correspond to the method field I was showing at the beginning of my talk, while showing the JSON, the Chrome Developer Tools protocol structure. So for every domain, we also have a special method called enable. So for example, here there is a method called network.enable, and this method allows to enable subscribing to the events corresponding to this domain. So when we execute this method, we will start getting any events occurring in the network. Okay, and we also have here a subsection called events with a list of network events, like for example network data received, which is fired when any network information was received, or network loading failed, which is sent when any network request fails. So here I'm demonstrating an example web application, and here we have an URL for this web page I'm testing. This is a very simple web application. It consists of one picture of the Chrome browser. It consists of the header. We have some network requests being received, and this is an HTML code of this page. So here we have some style sheet, CSS style sheet. We have also we have some script, which is just typing some messages to the console. And internally, here we have our browser automation project. This is a regular Maven project, consisting having several dependencies. The first one is Selenium. The second one is the Chrome Developer Tools protocol for Java. Also, we're using here JUnit 5. And so let's now take a look at the test code. So the test code, as usually, consists of some initialization method called setup. Here we initialize a standard Selenium session. Here we also initialize a Chrome Developer Tools web session. And so far as we are using Moon here in order to access this WebSocket with the Chrome Developer Tools protocol, we are using a special type of URL. So like this, /devtools/session identifier, in order to access this WebSocket. So and we also have here a test teardown method where we're actually closing our Chrome Developer Tools client, as well as we're actually closing our Selenium session. So in this example, we are using Selenium to start multiple browser sessions, and then we're able to use advanced Chrome Developer Tools sessions, Chrome Developer Tools features for every such session in parallel. Okay, so having this example, let's now take a look at what we could do with Chrome Developer Tools. The first one I would show you is mocking network requests. So here I'm showing the test where you can abort, or that means fail any of the network requests coming to the web page being tested. So in order to use this feature, I'm using a special Chrome Developer Tools section or domain called fetch, which is actually influencing how the browser will fetch any HTML or WebSocket requests. So in order to fail any requests, I'm subscribing to an event called onRequestPaused. And while I have any request paused, I can, for example, fail this request by providing its request identifier. And I also need to provide a URL pattern. That means a regular expression that will be used to match the request that we are going to fail. So in that case, I'm going to fail the request loading the Chrome picture in my example. So having this URL pattern, I just enable subscribing to any events in this domain and run the test. So after running the test, I will just take a look at the screenshot, and we can see on the screenshot now that there is no Chrome logo here just because its request was aborted. Another cool feature is mocking any network request, so you can just replace any request content, including AJAX requests, with any content you wish. So in that case, I'm going to replace Chrome logo with Firefox logo. So in the same project, I'm having a Firefox picture. So I'm reading the bytes of this picture. I encode all the bytes using the base 64 algorithm. I'm using just the same fetch domain. I wait for my request to be paused, I'm using just the same URL pattern for Chrome, a PNG picture, and instead of aborting the request, I'm using the fulfill request method, and here I insert the contents of my new picture of the Firefox browser. So now I can run my test, and when we take a look at the screenshot, we will see that the Chrome logo was actually replaced by the Firefox one. Okay, here is the Firefox logo. So, and the last example I will show you today is interacting with document object model and with CSS styles. So here I'm going to actually manipulate the DOM tree in browser. So here I'm using the DOM Chrome DevTools domain, and I can use just a regular CSS selectors to find any tags on the web page and to update their HTML with any content I wish. So in that case, I'm going to replace our picture with a regular text paragraph. So I'm running the test, and I will see right now on the screenshot that my picture, my Chrome logo, was replaced by the regular text. So here it is. I can also very easily take screenshots of any page element. So instead of using various different libraries for automatically cropping the full page screenshots, I can just take a screenshot of any element. So here I'm using a regular CSS selector. I'm getting the element, then I'm getting a stuff called box model, that is to say the coordinates, the width and height of the element. Then I create a viewport, that is to say the dimensions of the screenshots I'm going to take, and then just take a regular screenshot. So when I run this test, I will see that I will only take the screenshot of the Chrome logo. So here is the test. And when I open the screenshot, I'm seeing that a Chrome logo is only present on the screenshot. Okay. So the last thing I would like to show you here, I think, is highlighting nodes. So I can very easily find any element on the page. For example, here I'm going to find a header on the page, and then use an overlay domain to highlight this element, like you can do in the Chrome Developer Tools protocol inspector. So just take a look at this very straightforward code, and you will see that it's really easy. So when we run this test and take a look at the screenshot, we will see that on the screenshot this element is actually being highlighted like we can do in the web inspector. Okay. So there are a lot of different applications to the Chrome Developer Tools, and it's certainly impossible to show all of them in such short talk. But anyway, Chrome Developer Tools, I think Chrome Developer Tools is one of the ways to make your automated tests even more powerful, and by using them with Kubernetes you can dramatically decrease computing resources consumption. So we really think that Chrome Developer Tools plus Kubernetes is a powerful and cost-efficient automation that should become popular in the nearest future. So at the end of my talk, I'm showing some references, an URL, a GitHub URL on the Java project I was demonstrating right now, our Twitter, our Telegram channel, our website, and our YouTube channel, where we're actually posting a lot of interesting videos about efficient browser automation. So thank you for your attention, and feel free to ask us any questions using one of these possible ways. So thank you.